It's taking him to the registration site, it seems. Probably must be clicking something else. So I've sent him a link. So let the PPT be on, so that when people are entering, they need to see the title. Yeah.
All right. I think that should work.
Fantastic. Welcome, sir. Yeah. So shall we start?
Yeah, I'm ready.
Fantastic.
Sorry about that. Somehow this Zoom was giving me problems. Normally it does not.
No, actually, yeah, sometimes it happens. So welcome everyone. Happy Independence Day, 75th Independence Day. Today is August 15, 2021. Welcome to Self-Reliant India webinars by Siddhi. Today the topic will be India's 5GI standard, manufacturing ecosystem and impact by Professor Bhaskar Ramamurthy, Director, Indian Institute of Technology, Madras. The talk would be moderated by Mr. Anand Krishnan, Executive Vice President and Chief Technology Officer, Tata Consultancy Services. A few words about the Siddhi. Siddhi is actually a platform to create synergies for transforming India. It provides a platform to discuss socially relevant technologies by bringing together academia, industry, experts, policymakers, government officials, NGOs, social entrepreneurs, think tanks, and the general public. Agenda for today. Introduction will be by me, Sudarshan Padmanabhan, who is faculty anchor for Siddhi, IIT Madras. Welcome note will be by Professor Raghunathan Rangaswamy, Dean of Global Engagement, IIT Madras. The speaker will be introduced by Mr. Ananthakrishnan, who is a moderator, Executive Vice President and Chief Technology Officer, Tata Consultancy Services. And next, Mr. Ananthakrishnan will introduce Professor Bhaskar Ramamurthy. Then the talk will commence. And we'll have 15 minutes Q&A session after 40-45 minutes of the talk, and which will be moderated by Mr. Ananthakrishnan. The vote of thanks will be by Professor Preeti Agalayam, Professor of Chemical Engineering, also an Advisor of Office of Global Engagement, IIT Madras, Chennai, India. Without further ado, I request Professor Raghunathan Rangaswamy to take over and introduce the moderator. Thank you very much. Welcome.
Thank you, Sudarshan. So this is also 1 year since we started the Siddhi webinar series. Initially, we started this to commemorate the 150th birth anniversary of Mahatma Gandhi. And instead of doing just a few webinars, we thought we will do a webinar series which looks at the impact of technology with social relevance and so on. And it turns out actually, interestingly, that this has also become a webinar series for us to engage with a global audience. We've had several speakers from all over the world, and we also have global audience in our participants list. So in that sense, it's been an interesting experience. Now, for today, we have Professor Bhaskar Ramamurthy, who's going to talk about 5G. And we are really thankful and grateful to Mr. Ananthakrishnan for agreeing to moderate this talk in spite of his busy schedule. Mr. Ananthakrishnan is the CTO of TCS, as Sudarshan said, and he has managed research and innovation, open innovation networks, and interdisciplinary research in computer science and engineering at TCS. Without taking too much more time, I request Mr. Ananthakrishnan to introduce Professor Bhaskar Ramamurthy, and then we'll proceed. Thank you.
Thank you, Professor Rangaswamy, and thank you, Siddhi, for the opportunity to moderate this session. It's also the first joint session between Siddhi, IIT Madras alumni, and the IIT Alumni Center in Chennai. A quick word about the IIT Alumni Center in Chennai. This is also synonymous with the IIT Alumni Club, which has been in existence in Chennai since 2009. We have recently moved to the IIT Madras Research Park in a much larger facility. And in spite of the pandemic, we have managed to get the whole construction and other things well into way. So phase one of the Alumni Center is now open, and I welcome all of you who are Chennai residents to come and visit, and those of you who are outside Chennai as well. Whenever you are here, do come and see. It's a great physical, digital place now to engage with the institute, with the IIT ecosystem at large, and of course the IIT Madras Research Park to engage in activities of mutual benefit. And we hope that it will become a role model for many more such centers which are coming up. Bangalore Center should be up in a few months. And then Calcutta, Delhi, Bombay, Kanpur will also follow. And this movement will allow us to emulate many such similar institutions worldwide, which are run by alumni, but are for the benefit of the institutions that we all belong to. I am an IIT Delhi alumnus, and I'm proud to be hosting this particular session with Professor Bhaskar Ramurthy, who will be enlightening us on 5G and more specifically 5GI, the extension to the 5G standard, which has come about as a result of his personal efforts, but also a much larger ecosystem of academia and now more recently industry, which is trying to now get this India standard into the world attention. Professor Bhaskar Ramurthy really doesn't need too much of introduction, but even so, he is currently the director of IIT Madras and the honorary director of the Center for Excellence in Wireless Technology, CWIT, at IIT Madras Research Park. He's a former chairperson of TSDSI, the Telecom Standards Development Society of India. Many awards that I would not go through. He's also a personal friend and a colleague in many of these endeavors that we've been through together over the last 5 or 6 years. In fact, we both have been part of the high-level forum for 5G, which the government of India had set up several years ago. And now we are having an opportunity to look back and also look forward in this direction. So over to you, Professor Bhaskar Ramurthy, for your talk.
Thank you, Anant, and very happy Independence Day to all the viewers who are viewing this program. Good morning, good afternoon, good evening, depending on good night, where you are, wherever you are in the world. I'm very happy and pleased to be giving my first talk in the Siddhi series, though it started 1 year ago, and it's been a great series that the Institute has launched. Provided a tremendous platform. We never imagined it would grow into such a platform where people can interact and learn from each other. Also pleased that this is co-hosted today by the IIT Alumni Interaction Center, which is again, it's grown from the IIT Alumni Club, and it's come to the Research Park, and I think it's only going to be up and up from here. The kind of things that we're going to be able to do together, I think, are going to be fantastic, because I think the sky is the limit. So without further ado, let me get into the topic of today, which is this whole thing about 5G, 5GI, and so on. Actually, I have found it very difficult to find the title for today's talk, because I'm going to cover a small part of a big story, and this small part that I'm going to cover itself has many strands to it. So I just put together something that might give an indicator of what I'm going to cover, but I couldn't come up with a very apt or very concise title. So let me just share the presentation and get started. Why don't you just give me a few seconds? We'll share the presentation. Yeah. Okay, so the controlling it. So as I've sort of given a newer title to this talk today, See, India has been caught in a chakra view in the telecom sector. There are four things at least that I've indicated on the four sides of this picture. There is a global supply chain of which we are not a significant part, though we are the world's largest market by numbers and probably second or third largest even by value. We have huge negative foreign exchange outgo because we import a lot of stuff. We don't do much value addition in IP, or actually till recently not even in assembly and manufacturing, but now at least that has improved, but we don't do much value addition in terms of IP. I hope it's visible. Is the slide visible to everybody? Somebody should confirm.
Yes.
Thank you.
Yeah.
Okay. Okay. And with the advent of 4G and 5G, there are huge implications for national security, as I'm sure everybody knows because of the amount of debate in the media in all countries of the world. This work I'm going to report today, or the story I'm going to tell today, involves, as Anant was pointing out, a whole lot of people. So I just took this line from the great songs of the Beatles. Lots of help from my friends. It's not possible to really list the entire number. In fact, I'm a very small part of it in that sense. But I've been sort of, the oldest guy around in this business now, probably. And so I'm sort of, have a lead role to play in many things, but it's been done by a huge number of people. I'll try to indicate in the next slide a few of, institutions at least. So, a lot of major IITs are involved, IIScs involved. In fact, recently we have expanded out to another 3 institutions, but these are the institutions, and the people shown here are people from IIT Madras and CIVIT, but IIT Madras, but there's some 250 odd people who have been involved in this countrywide. A lot different parts of the story that I'm going to tell today.
Professor Bhaskar, it's still not in the slideshow mode. It's in the...
I don't know. I'm surprised. 1 second. Slideshow, Lilian. Just 1 second. It is in the slideshow here. I think just 1 second.
No, but we can also see the next slide, because of which it becomes smaller. That's it.
Yeah, that is the reason.
Okay. No problem. Next slide.
Duplicate slideshow in
No, but
display settings on
earlier,
top.
just 1 second. Earlier, just we'll get it right, because we tried it earlier and it was okay. So let me just.
So in the display settings on top, yeah, duplicate slideshow. Yeah, perfect.
Now it is
okay now?
Fine, fantastic.
Okay, thank you. Sorry, thank you very much for pointing that out. So as I said, a whole lot of people have been involved. It's impossible to name all of them. Different parts of the story, different people have been involved, but broadly they belong to a number of institutions. One of the things I'm very proud of is that this has become a truly national effort. And it's good. There's another, we are going on to the next phase of standardization with 8 institutions, really pulling in everybody who can contribute. And of course, industry is also involved, but they are not listed here. These are the anchor institutions that are driving the effort. Our challenge in telecom is, just 1 second.
Now we can't hear you, Professor Bhaskar.
All right. Okay. Our challenge in telecom is that we import almost everything. Our value addition in Indian manufacturing is low. However, the recent PLI scheme will reduce the FE deficit, foreign exchange deficit, through the volume game. There are no major Indian telecom manufacturers of network equipment. Though the technical capability is proven, there are companies that have shown they can do it. The value addition is also reasonable for telecom network equipment, but the volume scale is low. And there are large system integrators who have been integrating systems globally and setting up large networks and running them even. They have scale, but they have till now don't have their own technology. And the other important thing I'll point out to you is that there are key Indian requirements, additional requirements that we want from these technologies like 3G, 4G, and 5G, which have not been till recently met by global standards, simply because we were not even asking for it or not demanding that these requirements be met. There have been, even as I speak, there have been changes in this story. Things have been moving in the right direction. You must have read in the media last few weeks that that there is some aggregation going on. There are large companies that are now putting together, coalescing and getting to putting together a unit that can actually potentially be a major telecom manufacturer and supplier and integrator, like the few that are, the number of such companies globally are very few. You can count them on the digits of one hand. So, but India doesn't have one, and it looks hopeful now. But these have been our challenges. This is the chakra view that I'm mentioning before. Now this is not working. What's happening? Okay, now it's better. So our rural requirements in India, in fact, the rural requirements that have been there in the global standards till 5G came along was only to serve high-speed vehicles on highways. If you look at the requirements that standards had to that systems that defined by new standards had to meet in 3G and 4G, they only had to serve high-speed cars and trains on highways and tracks. And I've just given you the kind of configurations that they were tested against. Mostly you talk about, typically you have cell sites every mile or so, and then you're traveling at very high speed. And you should still be able to, in the days of 2G and 3G, you should be able to talk, and later on you should be able to have a decent data connection. But it does not at all address the broadband connectivity requirements of rural India, where we have 900 million people living in villages. As I say, I always like to say this, if you parachute anywhere in India, except probably in the hills, and walk in any direction, you will, within 2 kilometers, you will come to a village. There are habitations in every direction, and each one averages about 1,500 people. The fields around the village are where they work. And therefore, you need this kind of, and all these people have no other telephone except the wireless cell phone. And that's what they depend on for not just voice, but data. And because these standards don't address the requirement of providing such huge coverage over such a huge area, they actually, that's one of the reasons why we have had this problem of not being able to provide initially voice and now broadband to all our rural areas. Everybody knows that when you go into rural areas, you get coverage holes, and wherever the population is high, or near the railway track or near the highway, it works, but not otherwise. And this is one of the reasons that really the standards have not been designed to handle this requirement. So the rural network architecture in India is, the government has through a subsidy model taken fiber, or is in the process of almost completing the task of taking fiber to all the larger villages, which are called gram panchayats. And these are about a little more than a third of the total number of villages in the country. Number of villages in the country is about habitations about 650,000. These number about 250,000. And from there, you have to not only serve that village, which is large, but you also have to serve probably 3 or 4 villages around it. And this has to be done through wireless means. In due course, I'm sure if optical fiber will reach all the smaller habitations too, but it'll take time. The economics doesn't make sense today. Therefore, cell radius, this coverage cell radius, the mobility model, are you going to really, are these people going to be moving very fast? And what kind of spectral efficiency, what kind of capacity do you want? How much spectrum do you have? All these are going to matter a lot in deciding whether you're going to be able to do this well. So here is a distribution of the, from actual data. If you had a cell radius of 3.5 kilometers, you'll be covering about 70% of our villages, from the cell site. But only if you go to about 66 kilometer radius, will you be able to handle 95% of our villages. So this tells us that we should actually, if we were developing the standard out of India, we would actually try to make sure that we get reasonable performance, reasonable capacity with a 6 kilometer cell radius. And this is something that came out of our studies in the sort of around 2013, 14, and so on. And that's when TSDSI was also formed, and we decided to actively pursue this in ITU and try to make this a requirement for the 5G standard. We also had to do some channel measurements and modeling. Surprisingly, none of this, there's a fair amount of rural channel modeling done in Japan in 1960s and 70s, which actually led to even to the urban model that is used widely today, named after a gentleman called Hatta. But surprisingly, after that, there's been very little rural channel modeling. As you can see, the focus has always been on literally the one-dimensional problem on highways and trains. And I'm not saying we did a very comprehensive measurement campaign. It is very expensive and difficult to do this, but we did a reasonable job in some part of the country. And we worked with the Tyagaraja College of Engineering to do this. I want to acknowledge them. And the final, just to get to the bottom line, in ITU, we were able to present a new test environment, which is a rural enhanced mobile broadband. Enhanced mobile broadband is the jargon used for 5G, for the basic broadband application. And we gave numbers, what you must get per second per hertz, as the data rate, and the per transmit receive pair, and on the uplink too. And this was all done, spearheaded through the Indian Telecom Standards Body TSDSI, which was set up in 2013 itself after a fairly long effort by several of us. And the net result is when ITU firmed up all the requirements that had to be mandatorily met by 5G standard whenever it's developed and released, this finalization was done around 2016. And this is entirely due to India's efforts. And we got a lot of support from many other countries, especially the countries of Africa and so on, Latin America and so on. And the wording that is there in the ITU requirements for 5G, IMT 2020 as it's officially called by ITU, is that for the rural enhanced mobile broadband test environment, the average spectral efficiency should meet those values that I showed you for this thing called the low mobility large cell use case. So this terminology was also, this use case is also due to us. The words tell you everything. So the users in this use case are not moving at 120 kilometers per hour or 350 kilometers per hour. They are probably, many of them are not even moving. They're probably in their homes or in their fields, maybe walking. And some of them are maybe on 2-wheelers, 3-wheelers, 4-wheelers, and so on, moving at very, very modest speeds. But they are spread out over a coverage area. Actually, we wanted this ISD stands for inter-site distance. So it's sort of half of this is roughly the coverage radius. We wanted a coverage radius of 6,000 meters, 6 kilometers actually, if you remember. So we wanted an ISD of 12 kilometers, but at ITU, there were a lot of push back from many other countries, which didn't want to mess around with this at this late stage in 2016. And we had to compromise and agree to a 6,000 meter ISD, which actually is not, will only cover 70% of our villages. But this is a minimum requirement, and there's nothing preventing the standard from actually doing better. And that is what we went about trying to do. We said, well, this is okay as a requirement, but let's try to do better. And so this LMLC, low mobility large cell, has now become standard jargon, and everybody talks about it, and it's going to be there forever for 6G, 7G, and so on. So this was one major thing, major contribution that came out, at least putting our stake on the ground, saying countries like India, particularly India, and I'm sure others need this, and we jolly well want the standard to address this. Okay. Then I'm going to fast forward. I'm not going to tell you the story, in the way it evolved. Fast forward to 2020, and ITU actually received many candidate proposals for standards that meet the IMT 2020 requirements, including the LMLC requirement. And the main contribution, of course, comes from this very, very, very large and omnipresent global organization called 3GPP, which, as the name indicates, was assembled when 3G came up and has been, growing from strength to strength since then. It's sort of the global consortium of companies that have a stake in this business and that develop all the standards. They take it after that through their countries to ITU, and ITU then puts a stamp on it. These standards are too complicated to develop at ITU. So these companies do it, and 3GPP is an organization in which TSDSI is also a member organizational partner, and we actually participate there. And the 5G standard, as it's called today, is what went from 3GPP. TSDSI is also a proponent of that. But what happened is 3GPP did not balked at including the enhanced coverage that we wanted through some very important contributions that we took there. Some of it was included, but very watered down version. And we had to, at TSDSI, we actually put in those enhancements the way we wanted it and took it as an independent candidate to ITU. And both the 3GPP 5G and this TSDSI's candidate, which we christened as 5GI, both of them got approved. Both of them met all the requirements, was evaluated by independent evaluation bodies, and finally went through the step-by-step process that ITU adopts. And finally, both of them were approved as candidate standards for IMT 2020. This is the first for India. We've never taken a candidate standard anywhere to ITU before. And this part of the research on the standardization was supported by MIT at 5 institutes. And as I said, now we have expanded that to 8 for the next phase. This support from MIT has been there for more than a decade now. It takes that much time to get going on these matters. 5GI is actually based on the 3GPP 5G technology. As I said, we wanted to actually put it all in 5G, and it may still happen in a future version, but as of now, it's an enhancement. The picture on the right captures the what it is very well. It's a superset of 5G. It has some important changes in the modulation in the physical layer. It has an extra modulation mode and some few changes in the what are called radio resource control parameters, also associated with the radio, basically to achieve this enhanced coverage and capacity. And it's very important for us, as you can imagine, for the LMLC use case, our rural use case. What is the motivation for what we did? Well, globally, there's a feeling that, especially for the sparsely populated rural areas and the high-speed mobile application, that the 700 megahertz band, which is one of the bands for 5G, is pretty good enough to meet the requirements. The amount of spectrum available in this band is not very high, but if your population requirements are not, if the population is not very large, I think this will do. The advantage of 700 megahertz is that it's probably the lowest frequency at which cellular systems operate today. Long ago, they used to operate down at 450, but that's been more or less abandoned. And the lower the frequency, it's very simple physics, you get better coverage. But this amount of spectrum available in this band is simply not available. It's not enough for 900 million people doing all their broadband, all their Zoom calls, all their online teaching, learning, everything through the phone. It's just simply not enough. We have to use all the bands that are available for 5G, and the rest of and there are some more bands, between 700 and 2.3 gigahertz, which is written there, but many of them are also used for 4G, and their total bandwidth available is not that high. The real chunks of bandwidth are in 3.6 gigahertz and some in reasonable amount in 2.3, where 4G is already operating. So we really need to use this 3.6 gigahertz band if you want to get high bandwidth and high capacity. But at these high frequencies, propagation is poor. And it turns out that the coverage is actually uplink limited. Uplink in cellular jargon is the communication from the handset to the tower. Downlink is from the tower to the handset. It turns out that while the downlink works quite well, because you can imagine why, because the transmitters at the towers can transmit higher power and so on. There's more to it than that, but you can imagine. The uplink, the poor little handset struggles, okay? And one simple way to fix it is to actually increase the transmit power, the power of the transmit handset. Now, you can't do this in a safe fashion normally, because the handset is transmitting at a power level which is considered safe for human beings after many decades of observation. And but it turns out that these bands, these 2.3, 2.6, 3.6 are what are called time division duplex bands, TDD bands, whereas the 700 megahertz is an FDD band, frequency division duplex band. There's no need for us to go into what this is, but one implication of being TDD is that you don't transmit continuously. You transmit in a very short bursts, on and off, bursts that last fraction of a millisecond and then turn on every millisecond or so in 5G. The net result is the average transmit power is still lower than the peak transmit power. The peak transmit power is what you transmit during the burst. The average is when you average it out over the fact that you're not transmitting all the time. It turns out that while you need to increase the peak transmit power to improve the coverage, you don't need to increase the average. And the average is what matters from a health safety point of view. So while we maintain the average at 250 milliwatts or lower, we can actually transmit a higher peak power. This is not new. This was there in GSM, 2G. 2G phones actually have been doing this. And that's how you got very good coverage in 2G, despite there being fewer towers, or some of you may remember. So this is not a new idea. It's just that when things went to mostly to FDD in 3G and particularly in 3G, this sort of was lost sight of. So in 5GI, we actually doubled the peak handset transmit power without changing the average. Now this, you may say, what's the big deal in this? Why is this? Why does this call for any major standardization? Well, there are some problems if you do this. It turns out that the handset will require fairly new electronics, at least enhanced electronics, to be able to do this if you don't do something more. And what we had to do was actually play with the transmit waveform and bring in something called pi/2 BPSK, which I'm not going to discuss today, which as the next slide will tell you, enables pretty much the same handset electronics to do the job. So the question is, if you want to enhance the power in the uplink, will it actually require any major changes in the handset? And if you try to avoid changes in the handset, will it end up requiring major changes in the base station? Well, we had to do it in such a way that the answer to both of these is no, because otherwise, this is simply dead on arrival. Nobody is going to make very different systems just to handle India's rural areas, especially when the ability of that market to pay for it is quite modest. So we had to use, use our brains to try to come up with ways in which we can get what we want without having to spend for it. So it turns out that this pi/2 BPSK is actually something that is already supported by handsets which have 4G and 5G in it. Again, we'll just ignore the jargon. I don't even want to repeat it. It's not important. There's no new transmit hardware in the handset if it already supports 4G and 5G. Okay, there's some small tweak in the circuit, in the logic circuit, such a small tweak that it won't even show up in the area statement if you tweak the chip, but it has to be done. So a future release of the chip that you develop for 5G will have to have a small tweak to support this. But more importantly, the power amplifier, which actually has to deliver twice the punch, doesn't have to be changed. And that is because of the peculiarity of this pi/2 BPSK. It turns out that in all these handsets, you have to operate the power amplifiers at a lower transmit power than their rating. It's called a back off. And engineers know that in many things in life, you have to back off in order to ensure linearity. Engines operate at less than their maximum output thrust because of so many things, right? This is a very well-known thing that happens in most engineered systems. And so this power amplifier also has to be backed off. It has to be operated at typically at about 1/4 of its maximum power. And that's how it is in your 4G and 5G handsets. Now, it turns out that we can actually reduce the back off and operate it at half the rated power with this waveform, because this waveform has some features to it that doesn't tax the power amplifier, doesn't push the linearity of the power amplifier to non-linearities in the power amplifier. And therefore, it turns out the same power amplifier can give you twice the power that you want. And that is really why the handset doesn't undergo any changes. And yet we get the improved coverage on the uplink. Now we've done something, right? We've changed the waveforms on the transmitter. So obviously the base station receiver has to now be able to figure out what you're transmitting. So what does that do to the base stations? Well, again, thankfully, it changes only the decoding software. So base stations, most of the decoding is done it may not be in software running on general purpose processors. It may be software running in the form of an FPGA, but it's software. Finally, you have to change what's programmed into the base station. And therefore, this also can be done without any major implications for cost. There will be a development cycle time implication one time, but nothing more than that. So basically, what we did in a nutshell is to bring in what we needed as enhancements in a manner in which we would not have any major impact on the global supply chain ecosystem, either cost-wise or volume. In other words, we believe that we believed at the time we developed this that 5G handsets and base stations can become 5G plus 5GI handsets and base stations with no cost implication or even complexity implications, actually. So with this transmit mode, we can actually increase our coverage to 6 kilometers almost. And that's really what we wanted, right? So we got what we wanted. We also threw in a few software enhancements in the radio resource control parameters to go with this. These are all minor. We wouldn't have done this if we hadn't done the 5x2 BPSK, this is icing on the cake. If you're doing something, you always get an opportunity to fix a few other things, but these are not very major. But there's another issue, right? We may have ensured that 5G and 5GI handsets and base stations won't cost more or won't be divorced from the global supply chains for 5G. But when operators deploy these things, especially if 5GI is going to come later in availability and so on, how are they going? How is it going to work, right? How are you going to have interoperability? This can completely, if you don't have this can be a showstopper. So while we've ensured that you can add 5GI capability to 5G handsets and base stations without cost or complexity impact, can we make 5G handset work with 5GI base station and vice versa? Because that's really what we need. Have both standards coexist in the same network. And we are ensured, again, short answer to this is yes. You can actually make 5G plus 5GI base stations and handsets, and they can operate in either mode. If you have a base station deployed which happens to support only 5G, it can work with a 5GI handset or using it without the enhancements. And vice versa, if you have a 5GI handsets and it's talking to a 5G base station, if you have a 5GI base station is talking to a 5G handset, it will again work without the enhancements. And if you have a 5GI handset talking to a 5GI base station, then you'll get the performance improvement that you want. So this can also be done, and there are a couple of ways of doing this. One with a good liaison between 3GPP and TSGSI, and one without, and we are working on both. But this is very straightforward and can be ensured. So that's sort of one part of the story. One part of the story that started in about 2014-15 and ended in 2020, which is that India ensured that 5G leaves us with a very good potential to finally fix our rural coverage and rural digital divide problem, at least in terms of providing the network coverage that we need in a cost-effective way, and also enabled us to solve this problem with our own contributions, both to the IITU process by defining a new requirement that is very important for India, and in the standardization process by adding in enhancements, features in the standard that help to meet this requirement. But I also mentioned in the early first slide on the Chakravyuha that we have other problems. We don't have a manufacturing ecosystem. We import almost everything and so on. The country has been, moving in the right direction in that, especially by bringing in large-scale volume manufacturing, by making it attractive to assemble equipment in India for use here and export. So the last 3 years, at least, all smartphones sold in India are assembled in India, and now they're also being exported, as the Prime Minister mentioned today. But we really need to move beyond that, right? We need to add, we need to have much greater value addition. We need to become part of global supply chains with much more value addition and with our own IP too. So the mission in this project to build a 5G plus 5GI test bed completely end to end was supported by DOT in 2018, and it's ending now. It should have ended by April actually, but for the pandemic, it's been stretched to October, but we are finishing in October. This is being done by about 8 institutes. I showed you in the second slide. And the purpose of this was to build and to build a system that in the lab can be used for validating many 5G applications. As you all must have heard, 5G has a lot of applications, and for validating subsystems, startups that make maybe small base stations, maybe some IoT devices, maybe some smart meters. If they want to validate it before taking it to a potential customer for trial in a real network, nobody's going to let you try stuff in the network if they aren't reasonably sure it quacks like a duck. So, and particularly for startups, this was one of our aims. But we also had a second aim, which is that we want to license technology for hopefully a 5G manufacturing ecosystem that will evolve in the country. There are 250 plus engineers have been working on this at all these institutions, but 40 plus faculty have been involved, and many startups have been partnering with us in this exercise. This picture tries to capture a very busy picture. I don't want you to necessarily understand everything. Let me try to walk you through this. There is this thing called G-Node B, which is actually the gobbledygook in 5G for base station, what sits on the tower. And it actually, there are 2 frequency bands in which 5G has been developed. One is the 3.5 gigahertz band, what's called sub-6 gigahertz. 6 gigahertz is sort of a threshold in radio. Beyond that, you enter what's called the millimeter wave or microwave, and then millimeter wave. Millimeter wave is 25, 20, 30 gigahertz, that kind of frequency. And this is for the first time being used in mobile cellular communications. So there are two major, there's an entirely new very high frequency band around 26 gigahertz in India that is being used. And there's all, this bandwidths are very high, 100 megahertz in the sub-gigahertz, 400 megahertz in the millimeter wave. So you got to crunch enormous amounts of data in the baseband. So you got to build absolutely cutting edge baseband processing boards. Application side, UE stands for user equipment. You not only have phones, but you also have V2X, vehicle to vehicle, vehicles on the road talking to each other to intelligently navigate in the traffic and so on. And this is going to be a big application of 5G. At the user, Wi-Fi may be found insufficient if you have really high bandwidth, very high gigabit connections through the millimeter wave. You may need Li-Fi, as it's called, light, based on the lighting system in your room. So there's some work going on that also. And then if you go towards inside the network on the right, you have the 5G core. The 5G core is a completely new animal compared to the cores that came in 4G and 3G. It's entirely software running on data centers. And so this is entirely what's called software defined networks, and we have developed the entire 5G core in this project. There are lots of stuff that you need at the network at that end, which are outside the core. It's almost the tails that wag the dog, but we didn't build any of that. Those are all already available. The intelligent multimedia system and so on, and the servers that serve various applications, and then so all of this was being built by various parts of this various institutions. Some of them even in multiple institutions. Here's a picture. So I told you we're almost done. So this is a base station. What goes on the top of the tower, it might look like like a power box in your house, but actually this contains really cutting edge electronics, radio. The thermal engineering in this is as complicated as the electrical engineering, because there's a lot of power being transmitted and a lot of heat being generated. This goes on the tower top. Nowadays, it's not just the antenna that's on the tower top. In fact, what you see in front in the blue box is the antenna. And it's actually multiple antennas. It's actually at least 16 antennas, if not 64. And these are called massive MIMO systems. So this is actually a very, very sophisticated beast. And this is ready and working. And this is there in the test bed, but it can also be licensed. It works in 3.3 to 3.8 gigahertz band, 100 megahertz bandwidth, 16, 32, 64 active antenna system. It gets time synchronization from either GPS or NAVIC or from the optical fiber. It's connected by using fiber from the top of the tower. There's a new open radio access network standard that's emerging so that people can connect radios from anybody with baseband units from anybody else and so on, and it's compatible with that. It's probably we used to say earlier it's one of the lowest weight solutions, but I believe it is probably the lowest weight solution that's available today. But I think these people will keep coming up with new products. And it's ruggedized for all, it's on top of the tower. It has to withstand everything, cyclones, whatever, right? We've also done the same for this new frequency band that has come in 5G, never there in 4G and so on, 26 gigahertz, 28 gigahertz. This is all completely new electronics, very high frequency electronics. Even the chips that have been developed for this, of course, not in India, have been done for the first time. We ourselves are the guinea pig users of these chips. Bandwidth is very large. Antenna array is 256 in size. You can see the antenna array open there on the left. Small antenna elements. And the right side is when the whole thing is packaged together and so on. This is also very similar in the other one. It's tower top mounted and so on. Baseband, as I said, is very, very huge amount of processing you have to do. But ultimately, it's still a card that goes into a server that you buy from the market. This card has been developed at IIT Kanpur, and it supports all these humongous number of antennas. It's a very complex board, and it's all done and dusted. The board is all ready and working. It goes into any standard server, which you can put at the base of the tower. Actually, you can put it anywhere. It doesn't have to be at the tower, because remember, there's an optical fiber coming from the radio. This could be, a location that's common for many towers in an area, and this could all be located in a local data center if you want. Small because there's also something called edge computing that's coming up in 5G, that if you're having a lot of computing that need not go to some faraway point in the network, even in another city, because that'll choke the optical fiber network, you can actually push the computing to the edge. So there will probably be a lot of mini data centers, if you want to call them that emerge closer to the towers, and this could be actually where this could also sit where that data center is located. These base stations are full feature. There's nothing. These are not, there's nothing we have left out. This is what you can buy in the globally as I told you, from the leading suppliers of the world. I'm not going to go into all these acronyms. Frankly, even I don't know the expansions of some of these acronyms. My colleagues are the ones who know all of this stuff. But it's standard stuff. There may be some of you who know all of this, and I can assure you this is what you can get leading edge in the market. Supports all the formats, all the modulation, 25 users per time slot, huge number of users, can do a lot of massive MIMO, and so on. Gigabits per second of data rate. The core is also very important in 5G. As I said, it's completely new animal. And this has also been developed by CIVIT, IIT Bombay, and IIT Madras, and it's all done. This software was less affected during the pandemic, so we are a little ahead. We're almost done. I think September will be done. It's almost fully done. A version of it has already been, in fact, licensed to one of the companies in India. And this also uses a lot of latest technologies in software-defined networks. And that's listed below there. It's fully virtualized, cloud-enabled. Control plane uses service-based architecture. It's almost like plug and play of various modules. Control plane is segregated as per the software-defined network concepts. Very high-performance data plane. And there's something called network slicing. This is very important for India from a security point of view. Network slicing says in 5G that you can actually take a part of the network and slice it virtually, all the way from the core to the radio if you want, but including radio resources, even including spectrum. But very often people may do it only at the core. And the idea is this would give you guaranteed quality of service, irrespective of congestion in from other users in the network, particularly if the slice goes all the way to the spectral resources. But more importantly, it can have huge security implications. You can actually give a secure network slice, for example, to law enforcement, without their building their own network. You can imagine the kind of importance all of this will have in India, which is very cost-sensitive place where the law enforcement can usually not afford their own. I mean, they do have very elementary voice networks of their own. But if you notice in India, most policemen use their smartphones for anything else. And that's because the police cannot afford any expensive wireless data networks of their own. There is going to be a small, by commercial standards, network standards, small test network on IIT Madras campus by the end of the year, or maybe very early next year, using all this equipment. This will demonstrate both 5G and 5G. In fact, it will demonstrate this 5G plus 5GI kind of solution. And it will work with commercial handsets. We are not building a handset in the test bed. We're building other, tabletop kind of consumer user equipment, because we cannot build handsets in a project like this. But it will work with commercial handsets. And this just shows you, for those of you familiar with IIT, just tells you there'll be, we'll have tower, some transmitters in various parts of our academic area, and also one millimeter wave link going all the way to the research park. So what are we likely to see in the next 6 months? There are other parts of the story that I didn't cover today, which are all because actually what we are doing has to be plugged into the full story. Because as I told you, India is in a chakra view, and to get out of this is not easy. It's going to take a lot of things working out right. Many things have worked out in the last 1 year, and we are hopeful. One of the things that's going to happen, it's not directly anything to do with what I talked about today, is that there is a 4G core and RAN of Indian provenance, more than one, that is being tested in the BSNL network in the next 2-3 months. BSNL has already put out has already given sites to various such solutions. This is the real first time when especially an Indian core, which from a national security point of view is very important. And there are Indian RAN radio networks also, but RAN doesn't have to be Indian in this. It's being tested in the BSNL network. Till now, as you know, all the solutions in India are completely imported. And this is, if should these networks prove to be successful in the test, They are being tested because there are no large deployments. Normally any buyer will expect you to have a large deployment somewhere in the world, and it's a chicken and egg problem. So these are finally being tested. Chicken and egg problem can only be broken by becoming God. So finally, BSNL is giving an opportunity for these networks to show that they work. And then hopefully there will be an order placed, and hopefully the private operators will also start using, buying these net. But 4G is an old story now. So there is going to be a very quick upgrade to 5G in all these solutions, 5G plus 5GI. And the core for this has already been licensed to one vendor already, and we expect more licenses to happen from our testbed project, but there may be other solutions too. We are not necessarily the only ones building it. The RAN will also get licensed towards the end of the year. As I told you, it will be done only in October. And we expect, therefore, a fully Indian, more than one 4G plus 5G plus 5GI solution will be available 2022, probably the first half of 2022, which is globally competitive. As I told you, nothing, no quarter given. Every product will give you everything that you can buy in the world anywhere. It will be secure. The provenance is such that it will be security is assured. You might know that India has now got a process by which any telecom network equipment that is deployed in the country has to be certified as being from a trusted source. So while we are willing to trust other sources, which we have to, but it's obviously the level of trust goes up a lot if it's developed within the country, and significant value add. If this happens, if all of this happens, actually the value add in these products will be significant in the country. The chips in these products will still come from elsewhere, but a lot of the value is added here. And it interestingly addresses a very specific need in rural areas, which has not been met by 2G, 3G, or 4G. 2G was not too bad. It actually had better coverage than 4G for reasons that you can understand. 4G is operating at 2.3 gigahertz with much higher bandwidth, lower power. 2G had higher transmit power from the handsets, so operated lower frequency bands. So even now in some rural areas, your GSM phone will work, but your 4G connection will not work. So will all of this happen? Will we succeed? Will we trip up somewhere? Well, you have to stay tuned. You'll have to find out. Media is full of stories, true, partly true, and false. You'll have to, separate the wheat from the chaff, and you have to keep following the story. Stay tuned. It's interesting. This is one of the, things in this whole business of Atmanirbhar Bharat. Thank you. I believe I finished just on time.
Thank you, sir. Thank you, sir. That was a excellent summary of this almost decade-long journey into core, really high-tech, cutting-edge technology, and the complexities of doing this in a standardization world. There are lots of questions in the chat box, but I will summarize those in a minute. But if I, look at my own experience of working at it from my angle in this journey from about 2016 or so, from the software side, the computer science side, and then more recently in the standardization arena also. I would say that there are 3 or 4 very important lessons for India, and I'd just like your views on that. The first is that the need for us to develop core IP in this area especially has really come at the right time from the phase of India adopting technologies like 5G for our future. We did not play a big role in 2G standardization or 3G standardization and so on, but I think we got into it, into 3GPP, into IMT and so on. So the standardization journey, the importance of it, I think is only gone up from this project and many more to follow. Standardization by itself, I think, has taught us some lessons, that it has been dominated by, of course, the traditional European and American vendors, but more recently, the Chinese vendors and technologists have been playing a huge role, especially in 5G. And this game is a multi-year test match. It is not a T20 cricket match. You have to have a lot of patience and so on. So the first question that I would like to have is your view, sir, is that from the standardization angle, you have been personally, as well as India institutionally, has been using this LMLC and then what is now 5GI as our learning experience over the last 8 years as you have walked us through. As you look forward to the next decade, what would you like the Indian ecosystem to do in terms of playing a bigger role in the standards? And if I can paraphrase it to this audience, IITians, people in the technology world, alumni who may not be directly involved in this, how can we help to build the engagement with the technology creation as well as the standardization processes?
Okay. So, as you rightly pointed out, this has been a long struggle for us. It's almost like I think number of years wise, it's very similar to Rama's Vanvas, 14 years almost. We were asked to do this in 2006 by the government. Actually, academic institutions do participate in standards bodies, but peripherally compared to the companies. So this ought to have been done by companies from India, but companies don't exist. So what do you do? This is again a chicken and egg problem. So the government said, why don't you guys do it? So we started with just IIT Madras. Then we said we have to create a CIVIT. Then we tried to expand out to other institutions. Companies were still not happening. And one couple of people from companies also started coming and so on. And we got to go to standards meetings. It's as you said, it's a long test match. It's a lot of blood and sweat and toil, a lot of money. And government has been supportive, but our scale has been sub-scale. And if you at these meetings, we are a small group of people who turn up there compared to anybody, and size matters. But that's begun to change. TSD, not having a standards body of our own in India, all of these were handicaps. So we realized that we had to create something like TSDSI. It took us till 2013 to do that. So all of these were learnings, and now I think to come to the fast forward, I think we are in business. And just last week, MeitY has approved the next phase again with 8 institutions. Now many more institutions have people now, academics who now understand this kind of research. This is somewhat different from the kind of blue sky paper publishing research that we all do. And so we have a larger team now. One of the things that the 5G high level forum said is that we must have at least 20-25 teams, sub teams working on problems and going to standards body. I think we're getting to that number in this next phase, next 3 years. And it's just kicked off, 8 institutions. But still, this is, I would say, one, it's not the final, it's not the end stage, because academic institutions are not the prime movers in this business. And I think we are waiting. So the rest of the story that I mentioned, these 4G trials, the 5G, all of this is going to be important. We need large Indian companies to emerge and startups to emerge, and these should turn up at the standards bodies, and the academic institutions should partner with them to provide heft and muscle, but really it's the companies that have to turn up there. So TSDSI is also working actively on this. We want to have routinely 20, 25, 30 more people from these companies in India who have a stake in this business coming to the standards bodies with their proposals, with their ideas, maybe working jointly with academic institutions. All that is fine, but only academic institutions doing this in these standards bodies, there is a slight misfit there. Everybody else are companies. They have a stake in the whole game. We are sort of idea purveyors. We're not business purveyors. So there's a certain mismatch. And people wonder, why do you need to do this if you're not even going to build it? You're an academic institution, right? You're not going to build this stuff and supply it. So what the hell? So this is an issue that comes up. So I think we are at probably stage N-1. If we go in the right direction and manage to work our way out of the Chakravyu, I think there'll be a few companies. This is not Telecom has not been a game globally where there are very, very many large companies. India will probably end up having 2 at most. And then there'll be startups. Startups will work with companies, get bought by companies, all of that will happen, but that's the way it is. And so that's what we hope to see in the next few years. While we maintain the momentum in the next 3 years through this 8 institution project, I hope that by the end of the 3 years, we'll have many more companies coming to the standards bodies, and we move into the more conventional role for academic institutions, which is as partners to companies. Thank you.
So in that context, sir, I'll paraphrase my second question. And again, in the context of 5G and perhaps later generations, you mentioned the significant softwareization of the 5G technology, where especially on the beyond the network side, a lot of it is now pure software running on commodity servers with a custom built board, perhaps, and almost all the implementation being in software. And there, I think there is a lot of synergy which is feasible with the Indian expertise in software. I mean, not just our own homegrown software companies like TCS and so on, but also many of the multinational players who are in this area have their research labs and also their development labs in India, tapping into the software capabilities of the Indian ecosystem. So given that 5G, while we spent a lot of time on the enhanced mobile broadband aspect of 5G, especially the 5GI extension, but 5G also is an omnibus which has many other features. The so-called ultra-reliable low-latency promise of 5G, which says that you can run near real-time, almost real-time applications on a 5G network. The MMTC, the massive machine type communication, which brings in the whole IoT world into the scope of a 5G spectrum. That kind of bridges on the academic side, the computer sciences and the electronics, electrical, communications, telecom faculty, and that drives collaboration on the academia side. On the industry side, it is forcing, or not forcing, but enabling players like TCS, for example, or Tech Mahindra to actively participate in such thing, not just the Jios of the world or the Airtels of the world who are now stakeholders, but equally India's software industry now has a play. That I think has had a positive impact. Even at TSDSI now, we have a lot of the software companies as members. In fact, my colleague Ganapati Subramaniam is the chair of TSDSI who took over from you. And TCS is playing an active role in the institution. So do you think that this is the right direction for 5G standards and beyond? Now 6G is already on the standardization curve, so to speak. Are we on the right track? Is it somehow playing to our strengths now? We have a huge software industry, which is now beginning to get interested. And now will that be synergistic? Is that to our advantage?
Yes. So to re-emphasize what you mentioned, the 5G LMLC was just our entry point into certain parts of the ecosystem where we were not present. But 5G is actually all about low latency, the URLLC, new sub-millisecond latency link, which can be very useful for probably for India, for example, for remotely assisted surgery, just to give you an example, right? And machine type communications. I should have mentioned that in the 5G testbed project, we have also built an IoT chip. One of the institutions, IIT Hyderabad, has built a chip. So, and many companies are doing these things. So a lot of new machine type communication applications. And so 5G and this network slicing and so on, as I mentioned, 5G has a lot of things. A lot of Indian companies will play. Generally, you're right. There were this Chakravyuh had many barriers, right? So one of the barriers among them was the fact that even if it was a lot of software, as was true for the 4G core, for example, the 4G core the software was still running on a custom platform, a custom hardware platform, because that is the only way to get the performance that was required at that time. And that custom platform then becomes a barrier to entry. Even if you knew how to build it, the network, the telecom service provider doesn't want to, it's like buying planes. You may make a plane as good as Boeing or Airbus, but will somebody try you out? Will somebody take a chance? So, they won't. So that will be a barrier. And now with 5G running on custom, on commoditized hardware, the hardware is still highly reliable. It's because though it's commoditized, right? People are not questioning the reliability of servers that they buy from the big, from the global players, and you're able to ride on top of that. So the softwareization, in some sense, is not playing to our strength, but actually removing one of our weaknesses, one of the barriers to entry. That has certainly happened, and that's going to happen at multiple places in the telecom network. Though, as you come closer to the tower top and closer to the handset, it's still a game with custom hardware. And but fortunately, the tower top equipment is still programmable hardware. It's mostly FPGAs and stuff like that. So we are able to, again, the barrier to entry is a little less. Though you still have to prove, people still ask questions like, does your stuff really work 24/7? Will it work, right through the year? What is its reliability and so on? Handset is still, of course, a very sophisticated chip that has been made every 2 years. So but the rest of it, a lot of it is, and a lot of the new applications in 5G are going to be heavily software driven. So there's an opportunity for companies to break. But to think that somehow it's all software now, so it's our play is not correct. I think that's complacency. That's complacency. That's just not warranted. I think it just does reduce some of the barriers to entry. And in all these things, we look at stories. We look at how Korea broke into wireless with 3G. We look at how Chinese broke into wireless with 4G into the ecosystem. It's always about taking advantage of an opening, and then doing everything that others are doing as well as they do, and then becoming part of the ecosystem, global supply chain. So the opening for us has emerged. It's not yet fully opened. I think we still have a few months to go, as I said, to make sure we get it all right. But then we have to do everything well and better than others, and have companies and make good products and innovate and come out with new ideas, come out with new IP and so on. But yes, some of the barriers to doing that have disappeared.
Hopefully it will go well, sir. My last question is a sort of a paraphrase of 3 or 4 classes of questions. There are more than 60 questions on the chat question answer box. I'll try to bring that into. So the focus of this is on one side on the cybersecurity aspect that you briefly touched on, and network slicing as one specific feature in 5G which can actually improve the security of a 5G network. Secondly, the trusted part of the certification required on both the hardware as well as the software stack. And thirdly, on the Open RAN view that you had briefly mentioned in one of your slides, and the fact that open source is going to play a bigger and bigger role. In fact, just for this audience, I was part of the HLF, as I say, high-level forum, and we have recommended to the government that open source should play a bigger role on the application side as well. In fact, there should be an open source application reference stack, just like we have an Indian reference architecture for the 5G core and the antennas. We said that for the application layers also we should have an open source stack. So given that open source is one way of making a software stack more inspectable by a larger community and therefore hopefully more trustworthy. Secondly, 5G itself is more trustworthy in some sense because it can offer network slicing and therefore privacy amongst multiple users of the network, perhaps for very different applications. And thirdly, on the softwareization, which we just discussed, is there a set of risks that 5G will actually reduce for the Indian ecosystem if we get all these right? We get the softwareization right, we get the open source right, we get the network slicing and other things right. Is that 5G security concern controllable with just these, or do we need something more?
See, this is commercial technology. This is not military technology. So I think we have to understand that these are complex global supply chains. And I think it's foolish to think that we'll make everything. And in fact, probably the wrong thing to even imagine, give alone try. I think the point is to be important parts, important cogs in the wheel. Partly, your own security is actually a combination of knowing deeply what's in it, being able to make right decisions about how to put things together with the minimal risk at every stage, as you say, depending more on open source, depending, on all kinds of things. I mean, just the ability to potentially discover if there has been a breach can sometimes prevent a breach, even if it is possible, right? So I think you need to have that kind of strength. So I think if you're a part of the global supply chains, a significant part of the global supply chains, I think even if there are vulnerabilities, it's not obvious that they'll be exploited in a routine fashion, because there's a price to pay if you're caught out. So I think I don't want to be more specific than that, but I think basically the way to do this is to actually as you say, we are a large country, we have a lot of the capability, have players who are globally competitive, who make many of these things, not necessarily all by themselves, but in partnerships, by putting things together, using things that others do much better than us and so on. But having a control, knowing what's going on, doing this knowledgeably. The evaluation of the product can also be done by looking at what's coming from where, what's being put together, which is less vulnerable, which is more vulnerable, and so on. And then if you are also a part of the global supply chains, you have a significant stake in it, others have a stake in it. People don't hurt, people living in a community with the dependence on each other don't hurt each other. Okay, this is a very simple thing. You see this in our communities, in our physical communities, right? So it's the same.
That's, I think, a good way of putting it, sir, that India has now got a credible face in the global community now, and hopefully we'll get it right and get it into the right value chains. And that by itself will give us the confidence that we will be, shall we say, more secure.
I think if you are following this story in the media and various stories, when you see some of the opposition, you have to, and you wonder why, you have to understand that well-settled communities don't necessarily want a new entrant who brings in uncertainty. Mm-hmm. Okay. So it may not be anything more than that. Right. It's not a war. It's just a small battle, right? But you have to win the battle.
Thank you, sir. And thank you for that very enlightening talk. And I'm sure the audience has taken away a lot. There are many, many more questions.
You also asked about how alumni can help. Actually, you go to any of these meetings, you go to 3GPP, it's all our alumni sitting there. Okay. I'm not saying they should do anything more than, they should do their job. But really, alumni can help in this in any way they want. If they feel they want to be part of this exciting story in India, they can participate, right? They can create their own startups, they can join companies, they can mentor, they can do whatever they want. But frankly, when I go to 3GPP, not just alumni, many of them are my students. Sitting in various positions, both supporting and opposing. So it's all part of it. I understood a little bit of the Mahabharata after this. Right, when you have all these teachers and students on both sides. Yeah, I understood it. Suddenly it flashed on me. Oh, this is what it is. Okay.
Maybe the alumni center will have a more amenable place to meet, and
it's all very amenable. We all go to dinner together there also. It's not that also happened in the Mahabharata, right? After sundown. Yeah. It's all
excellent.
Yeah.
Super. So I think the Chakra view we started with, and we're ending on the Mahabharata. Right. So with that, let me thank you once again for this, and I'll now hand over to Dr. Preeti for closing out the session. Thank you so much, sir.
Thank you, Mr. Anant Krishnan. I will start by formally thanking you for taking up this role and moderating the session so beautifully. It was lovely to see Professor Bhaskar so animated, especially in the
I've never had a chance to talk technical stuff. I always do administrative stuff. This is probably long. I do this for other forums, but not in the IIT.
Absolutely. And I think large part
of me smile because I'm so happy doing this than the usual administrative stuff, right? Okay.
Really. And I think it was the curating of the questions and the moderation.
Yeah, absolutely.
And Krishnan, I'd like to thank you from the bottom of my heart for that. Thanks, of course, to Professor Bhaskar for such a lovely talk, going from Chakraview to Gobbledygook to Beatles in between and so on. Lot of the technical part was, of course, above this chemical engineer's head, but it was very interesting. And thank you so much for, despite the schedule, taking the time out to put together this session for us.
Thank you for giving me the opportunity. I think the Siddhi platform is a very good one from what I hear. People are really enjoying it. I hope it goes from strength to strength.
Thank you, Professor. Also, of course, big thanks to Professor Raghu, Dean Global Engagement, for supporting this. And of course, for Sudarshan for all the ideation and all the hand-holding, along with the team that does it. And of course, Karthik is on this call as well, Professor Karthik. Also, thanks to you and your team for the flawless execution of this session. I think with these words, I'm done. Thank you, audience, for all the questions. And bye and good night. Sudarshan, I don't know if you have anything more to add.
Wish you all a very happy Independence Day, 75th Independence Day. Thank you for all the support. Thank you. Good night.
Thank you. Good night.
Thank you.
Good night.